All right, we're going to get started now. Hi, good afternoon. This is Tara Van Cleve, and welcome to the Compute Cloud Coaching session. Before we get started, please know that this session is being audio taped and will be available after the event to view at your convenience. Please feel free to ask any questions in the Zoom chat, and we will happily answer them after the topic presentation, along with any pre-submitted questions. And so, without further ado, please welcome our cloud expert, Mark Smith.
Hi, thank you, Tara, and welcome everyone. For those who are joining for the first time, welcome. For those who've come back, thanks for returning. Today, as mentioned, I'll be talking a little bit about Oracle Cloud Infrastructure, specifically the compute resources, which, as many of you know, form sort of the foundation of what we do in the cloud. So first things first, of course, we'll present the safe harbor statement and give you just a second to read that. And then here I'll show you just a brief agenda. What we're going to talk about today are, of course, the compute, all the different kinds of concepts and ideas within the compute resource section that you'll need to know or that will be very helpful for you in building out your cloud environment. Of course, the bare metal and VMs are sort of those key instance features that we talk about, as well as scaling, how to go up or down when you're using those resources. And then just to tail it off at the very end, I'll briefly touch on container engine and functions. Now, both of those topics merit their own entire presentation, and so I'll touch on them very lightly, simply because understanding the core foundations of the compute resources behind them or that support them are very important, and so we'll just touch on that portion of it instead of how to deploy or anything too complex like that. So with that, let me show you this as a kind of an overview. When you're considering or comparing or trying to understand all of the different potential pieces of compute that you could use, here are sort of the most notable. On the far left-hand side, you'll see bare metal, and on the far right, functions. As you move from left to right along this path, you'll notice that there's more to do on the left than there is to do on the right. So all of those pieces that are outlined below are the pieces that you as a cloud user are responsible for if you select or choose that compute resource. So on the far left, again, bare metal, you have the compute, the app container, the language runtime, operating system, and virtualization are all part of the bare metal machine. And as you move right, dedicated virtual hosts and virtual machines are essentially the same thing, but there's a key difference in there being a multi-tenant versus a dedicated resource. But you can also see that virtualization drops off the end. So that would be the key differentiation between bare metal and any kind of virtual machines that you're using, is that the virtualization then falls off, and that's managed by the cloud provider, in this case being Oracle. And you'll see as you move to container engine that you lose a few others, such as the language runtime and operating system. Those again become something that the cloud provider touches or completely manages, and so that will essentially take that off of your plate, making it easier to run container engines in a sense because you don't have to worry about those pieces. And finally, functions, where in essence you are only really dealing with a certain specific piece of code. All of the other pieces of the compute or the cloud stack are run by the cloud provider, and so you don't even have to worry about that. So with that, just kind of understanding that as an overview, we'll go in and we'll touch on and talk about each of these individually. So first of all, let's talk about bare metal, and then VM, we'll talk about dedicated hosts as well. So what is a bare metal? This has come to be a term used more widely in the past few years. This is direct hardware access. This is where you as a customer have a full bare metal server dedicated to you. As mentioned there, it is single tenant. And so that entire server, you never have to worry about noisy neighbors. You don't have to worry about it being overbooked or oversubscribed unless you yourself do it, right? So everything there on that bare metal server allows you to do it by yourself or on your own. Again, on that bare metal, there's no VMs. So when you do move into a situation where you're talking about using virtual machines, that's where we see the important addition here of what's called a hypervisor. And the hypervisor essentially is a piece of software that's attached to a bare metal server. So the underlying bare metal server stays the same, but what we do with the hypervisor is it divides up the bare metal server virtually and creates what are sort of separate compartments within your bare metal server. And we call each of these a VM. Now, with the typical setup, your VMs will be multi-tenant. That means that you will have other customers or other Oracle customers operating on your same bare metal server, but in a separate virtual machine compartment. So obviously we'd love to say that there's still no overlap or anything like that, and that's the case. But this does lend itself sometimes to those phenomena or those problems of noisy neighbors. So that's why this is dedicated or written in as a multi-tenant solution, and that's why those different colors there in the hypervisor. Now, there is a third option, which is kind of a best of both worlds, which is what we call a dedicated virtual machine host. Now, this runs the same as the others on the bare metal server, and it is provisioned with a hypervisor that does allow different virtual machines to be running on top. But the difference here is that you're paying for, or you're reserving for yourself, that entire bare metal, including all of the different VM compartments. So in this instance, you can see that all those instances there are all that kind of yellowish or beige color. That's signifying that there is still only one single tenant, which is yourself. Therefore, you're not in a multi-tenant environment or anything like that. And this definitely has its perks, but obviously because of the amount of resources that are being designated to you, this will probably come with a higher price tag. Sorry. As I mentioned before, all of these offerings all run on the same basic hardware as a bare metal server. So these instances are leveraging all of the same resources. They've all been treated the same in terms of being optimized. All of the software, firmware, etc., all of the networking resources are all the same. And why does that matter? Is because when you start discussing things like making API calls or whatever, it's the same. It's universal across these because they all come from the same base foundation. So next, let's look a little bit about when you would use bare metal versus VMs and what are some of the use cases. As mentioned, again, this is your direct access. You have all of that entire server with you. One use case is workloads that are very performance intensive. So if you are running, for example, complex simulations, or we saw quite an explosion during COVID for a lot of these workloads that were trying to determine vaccine usage and things like that, or trying to do complex simulations around whether or not certain things would work. All the computations behind that were very performance intensive, and so very much a use case for bare metal servers or bare metal machines. Next is workloads that are not virtualized. Now, in the cloud world, it seems like so many things are changing. There are still a good amount of workloads that are not virtualized. In many instances, customers prefer to have their database not virtualized. So that's one specific use case where bare metal becomes in very handy and is very useful. Next is if you have any kind of workload or any kind of requirements that require you to have a specific type of hypervisor. And in that case, you are responsible, obviously, for provisioning the hypervisor, maintaining it, putting everything in there that you need, and making sure that it meets all the specification requirements that you have. And finally, workloads that require bring your own licensing. There are instances where this is required, whether it's regulatory or simply because of security concerns. But in that instance, bare metal is also probably the best option for you to choose. How does that vary, or how is that different from VM? Well, of course, again, we have the hypervisor on top, and VM has become sort of the standard. It's sort of ubiquitous in all of the cloud computing, and you use this when you want to control everything, all of the aspects of that environment. You can use it for deploying a legacy app, and this kind of goes hand in hand with that third bullet point there is you can use VMs to move applications from your on-premises environment and move it over to the cloud. Because everything is owned and controlled by you, you can set that VM up in such a way that it's easy to make the move over. Whereas, you may have to do a lot more work to fit something to fit a bare metal. When you set up your VM, you can set it up in such a way that all the work is on this side as opposed to trying to custom fit your application or something like that. That does come with a trade-off, obviously. Whenever you have full control over anything, that means you're responsible for the work as well. So all of these things that are listed below, patch management, security, etc., all of those then become something that has to be done or maintained on that VM. So there is a trade-off in all of this, right? Work or feasibility or ease of use. Now I'm going to go into a couple of things that apply to instance basics, and the reason why I didn't start with this is because this applies to both bare metal and VMs. So I'll just make sure that you know that this applies to everything that we're talking about or have talked about thus far. So first thing you should know is there is a huge variety of instances. There's sizes, what they call shapes, for every different kind of workload. And for those who are potentially or possibly brand new to cloud computing, when you think of compute, you should think of this very much like your basic processing power that you would have in, say, a desktop PC or a laptop. Right? Compute is that resource behind the scenes that is running everything, that is running the computations and the operations and everything else. And obviously, CPUs, RAM, and bandwidth, those can all change, and they should in the cloud, depending on how you're architecting your solutions and what workloads you'll be running. You should take note and plan accordingly by building or selecting the correct shapes for your instances. We as Oracle, as a provider, do support both Intel and AMD, and we do have very competitive pricing and performance measures, as well as service level agreements, which will, SLAs that are baked into every one of our contracts. And also, we provide what are called GPUs, or graphical processing units, and HPC, or high performance compute. So you can think of the graphical processing unit as your graphics card, essentially, for your laptop or desktop. It's a very similar concept or idea. And then if you have something, say, that's rendering images, workloads where you're having to do a lot of image processing or something like that, you would need, obviously, a shape that has a GPU included. And just so all of these other things here, this last bullet point basically says that all of this is guaranteed. It sits within the Oracle virtual network, and it takes advantage of all of those connectivity, security options and everything as well, and can even be done, hopefully, for your on-premises stuff as well. So to look at this a little bit graphically, I have a little bit of an image here, and that top point is important, is that these compute instances do depend on or rely on outside resources. And so that's why, again, if you've come back, this is our third session. We talked about identity and access management before. We talked about networking, because all of those go into what is part of the compute environment. So, oftentimes we're just talking about the instance, but it's good to understand that these other pieces come into play here. You'll see the boot volume disk, or the OS disk, the operating system disk, block volumes, which are basically our data disks or storage, and then obviously the networking components, which are our virtual cloud networks, and a VNIC, which is a virtual network interface card. And I'll show you these here in a little bit better diagram, just so you can kind of see what an architecture looks like. This is the basic Oracle Cloud Infrastructure setup, where we have a region, which is a geographical region, and within that region we have an availability domain. So within that availability domain, and sorry, those top two levels are physical, right? That's the hardware. That's where Oracle's servers are all housed, and everything else, that's the data center. Now this dotted line box is our VCN, which is, of course, a logical construct. So within the cloud itself, we've created this networking space. And within that, we place our subnets. If you haven't watched our other presentations, I'd encourage you to go back and watch that. Those will explain a little bit better what a VNIC or a VCN and a subnet do, and why they're important. Now, when we talk about these instances, oftentimes we talk about the instance being inside or within that subnet. And that's not strictly speaking true, because the hardware obviously sits in its own data center, right? These virtual constructs don't necessarily have that inside them. But what we do is there's a physical virtual network interface card, or VNIC, which sits on that instance, and then that is virtualized into the subnet. And so that's how these instances, quote unquote, sit within the subnet. It's because, and why do we do that? Is so you can attach IPs, public IPs, private IPs, and things like that. Now, outside of that, also, we will have different key pieces that are important to it, which is, for example, our boot block volume and our data block volume. And you might ask, why not have storage just right on the instance? Well, we do, actually. So many of these instances, depending on the shape or size, does have inherent storage or memory that you can keep on the instance itself. Now, the problem with that, obviously, is if the instance goes down, then that becomes a single point of failure. And you could potentially lose the data that is stored just on the instance itself. So in these situations, we typically, best practice-wise, always suggest that you keep some of this data or most of this data externally, and then that way, if you have or run into any problems with your instance itself, it goes down or dies, you can spin up a different instance, you'll still be able to access your data. So hopefully graphically, from an architectural standpoint, that gives you a little bit better understanding of how this all works and looks. Now, I'm going to show you, I'm going to switch real quick to the console, and I'm going to show you what it looks like within the Oracle Cloud Infrastructure console to be able to spin up an instance. So first things first, this is the main landing page. So if you were just to come here, these are all the options you would see. And first thing, click on the hamburger menu in the top left-hand corner and select Compute. And within here, you'll see that there are various options again on the left-hand side, depending on what you need to be doing. And of course, it's going to give me an error. So let me double check and see if I can do this. So if I want to create an instance, let's click on Create Instance, and it will begin to populate. And I may be running into some issues, but in instance, what you would do is you would name your instance. You would select the compartment where it sits. You can see that we have a whole bunch of different ones. I already know that I want to be in my own compartment. And then as you come down through here, you'll have the option or the opportunity to actually choose where you want this to sit. So within your larger Oracle tenancy, you will be, probably in one of these data centers here. Mine's are, of course, in Ashburn. Within there, if you decide that you want to determine the fault domains or the availability domains within which these are located or placed, you can actually do that. You can drill down in here and then you can choose. And then let me see if this will give me the option. Let me, you all know how it works to do live demos, of course. You're going to run into issues no matter what you do. So let me double check and see if I can just refresh this so I can get you a better view of how this all works. Okay. Now the image, if this populates correctly, will give us options where we can choose, for example, Linux or Windows images that we want to use. And then shape are the derivative pieces of that. So, if we had selected, say, an Oracle Linux, then when we go in here and we wanted to change the shape, you'll see that we have options for either a bare metal or a virtual machine. And of course, if you pick bare metal, you'll have certain specific options. There are fewer of these because of the bare metal requirements. But you can see here that all of these metrics change, right? Your OCPU, basically your throughput or how quickly it's operating. You have memory, storage, and then you actually have a couple specifications here, how many total VNICs can be attached, what your network bandwidth is, et cetera, et cetera. And you'll see even here in the names, this is a GPU shape, so it is a graphical processing unit as well. And this is one that's been designated for HPC or high performance workloads, by the way it works, right? So we make those all available. And now that they're popping up here, you can see a little bit, you can change the image. So Oracle has some predefined images, and you can select any of these, right? They're already pre-configured, and the system knows exactly what to do with all of those. You can select other Oracle images. Now, these are images that have been created for specific uses. Say, for example, you have, or you're running JD Edwards. In this instance, you can go in and you can select that. It's an instance that's pre-configured and optimized for a JD Edwards deployment. And we even have in here some partner images that our partners have created and have been vetted and essentially signed off by Oracle. And these are for running up, obviously, workloads that those partners support. Now, it's running a little bit slow again, but you can imagine from the out, oh, there we go. So you can see that there are a couple of these, right? Basically, if you have some of these options that you're already working with or something like that, Blue Prism, for example, you could do that. Now, if I click on custom images here, there is the option to create. We don't have any in here. I don't have any. And you can actually even go in and create your own kinds of boot volumes specifically to the images that you want. But again, there won't be anything in here because I haven't created any in this instance. And then looking again at the shape here, you can choose what kind that you want. If I just go with an AMD, then it will give me the opportunity to select a number of OCPUs, right? I have the opportunity here to scale up or scale down. And then of course, when I finally am done, I can just go ahead and select that shape. And then the networking configuring, I will actually leave out for right now since we discussed that a little bit later. But suffice it to say that in this, you can determine which networks and subnets you want your instances to be attached to or operating within. And you can even select here if you have advanced security roles or groups. You can click on that and attach, as soon as it's made and created, you can attach it to an already existing security group. You can choose here whether or not you want public or private IP addresses. For my purposes, it doesn't make any real difference, so I'm just going to leave it. In this instance here, in this section here, what we're talking about is how to add SSH keys. And this can be something where you are managing your own keys, you want to generate a key, or choose a public-private key pair. For me, I never would recommend this to anyone to never use SSH keys because this governs your ability to SSH into this machine. And if, for example, if you were to lose some kind of, or have some kind of problems with your machine, you would want to be able to SSH in so that you could try and troubleshoot. So, but for right now, I'm going to choose no SSH keys just for ease. And then you can go in here, and again, as I said, if you've created a specific boot volume that you want to use, you can click here and do that. And then some of these advanced options are around management. You can see about tagging, a few advanced networking options and images. But for right now, since this is just kind of more of a beginner, I'm going to go ahead and just hide those, and I'll create. Obviously, I'm having trouble with my environment today, but that's okay because really all this would do is it would take you to a screen where it would say provisioning, and you would see how long it would take. It would take a couple minutes to show. Oh, you know what? Probably why? Because when I rebooted, it put me on the wrong environment. There we go. Sorry about that. So if I were to repeat that process here, it would be all the same process, but because I just showed it, there's no real worry about that. So with that, those are why I address some of these core concepts and thought processes, is because when you do go into the console, you'll have to know a few things as to, what's my workload like? What am I running? Why do I want to have this OCPU count versus something else? How big does my memory need to be, etc. And then for networking and things, where do I want it to sit, in which availability domain, fault of it, etc. So let me go back then to this, and I'll talk a little bit about scaling. So one of the very important things, and obviously one of the beauties of cloud computing, is that you can take what you've created and you can scale up or down. So the first kind of scaling I'm going to talk about is what we call vertical scaling. And this is scaling up or down. Typically, this is the vernacular that's used, and this is your instance shape. When you do this, essentially what you're doing is you're saying that I want to take this shape and I want to add more resources within that shape. So this is taking your VM standard and adding OCPU counts or memory or something to that effect, right? So you're not building completely new instances. You're not building a copy of the instance. You're making the instance itself bigger. And these points on the left-hand side is, any new shape that you're going to do has to have the same architecture. And to do this, you will have to stop. the instance. So you have to shut it down for a few minutes, do the resizing or the scaling, and then you can bring it back up. So sorry about that, I skipped ahead a little bit. But so again, this is vertical scaling. It gives you the opportunity to do this within the instance itself. Now, the horizontal scaling, or what's oftentimes called auto scaling, is probably the kind of scaling that you are generally thinking about when you're talking about auto scaling. This is where you're actually taking one VM instance or one type of shape, and you're building basically more of it. So instead of creating some changes within the instance itself, you're just basically duplicating or replicating that and providing it across. Now, as you can see on this left-hand side here, this one is gray and the others are kind of the yellowish color again. That's by design, of course. These three are going to be the new virtual machines that come. And that first initial left one in gray is typically what we call a gold image, where you've pre-configured that image to be exactly what you want it to be, and everything you need, and you know that whatever you're scaling up to is going to match all of those same specifications. So this is again called scale out or scale in, and you can do this both ways. So the beauty of this is that if you want to scale up, or you're, say, a retailer where you have high demand on, Black Friday or something like that, well, there's no need to keep everything running all year round when you can simply scale up during those months, October, November, December type time frame, and then you could then scale back down when that demand goes away. This is also good for sort of high availability situations where if one VM fails in this group, then you can have others who will take up its place. And then you can, again, match that demand going up or down. And also a great thing is there's no extra cost for using this auto scaling feature. Obviously, you have to pay for whatever resources you're using. So as you scale up, if you're using those resources, you'll be charged for what the usage is. But there's no extra hidden fee or cost where, every time you scale up to a new instance, we're going to charge you, 50 cents or $100 or something like that. That's not the case. So how do you set this up? What does it look like? So for auto scaling setup, it's actually fairly simple. You take a running instance, you make sure that all the specifications within that instance are what you want for the future instances. For example, operating system, metadata, etc. And then we create what's called a config file or configuration file. That essentially saves all of those in kind of a metadata format where it has all the details. And then you use the config file to create what we call an instance pool. And this is essentially just a grouping of all of the new instances that you plan to create. And you can put them in different availability domains. You can manage them all together. So this is great if, say, for example, you had a use case where, again, you had a customer-facing website and you needed to just be able to quickly scale up and provide more instances to manage traffic. Or let's say, for example, you are working with developers and you need to provide each developer with their own environment. So you can go in, set up a gold standard with all the specifications that your development team needs, and then you can automatically scale up in this instance pool and provide as many as you need for as many developers. Then all of those instances can also be managed from a single console, and you can write rules or policies or delete or change them all from this one instance pool console. So just to visualize that, obviously minimum size for your instance pool is 1, and then let's just say for a sake of example here that we're starting with 2 is our initial size. And this is our instance pool before anything happens to it, right? This is just what we've set up in our own without any kind of scaling to happen so far. Then we can create a scaling rule that will tell us, for example, just below that, if CPU or memory utilization meets or exceeds 70%, our rule specifies that it will then add 2 instances. And we can write the same sort of reciprocal rule as well. If the CPU or memory utilization falls below 70%, we're going to remove 2 instances. Now, obviously, this should be set based on whatever the demands of your business or workload. Those numbers can change. You can put it up to 50 or put it down to 50, or you could say, hey, as soon as memory utilization reaches 70, let's upscale or scale up. But on the reverse, I want to wait until my utilization goes down to 50 or maybe even 40 before we scale back down. So all of that is user defined and can be set based on your specifications. So this is sort of what we would look like afterwards, right? And you can set a maximum size. So if you you never want to be completely crazy about it, or you're afraid that potentially somebody in your organization for whatever reason will be confused and scale up too many, you can set a maximum size. You can set limits so that somebody isn't going in there and automatically scaling up to, say, 100 instances or something like that. So in essence, that's how our auto scaling works. And let me just show you within the console how that looks. It's actually also a fairly simple process for doing this. So while we're still on our instances page, I'm going to go ahead and just click on this already running VM. And in this on this instance, this compute instance, and here you'll see all of the different specifications. You can check public IP, you can get your OSID or your identifying characteristics. You can understand what's attached here, the boot volume and everything else. And so now that you have that, all you need to do is click on More Actions, and you can click Create Instance Configuration. Within this, give it a name, and I can't type. And this will create an instance configuration based on everything that we already have in that instance itself. Now, this is pretty quick, it's pretty easy. And the very next pool, all we need to do then is create an instance pool off of this. Now within this, again, we can just give it our own name. And we can provide the number of instances or determine the number of instances that we want to have in that. And we can change the compartment and everything else. But for right now, I'll just go. And you can see here on this side, if you're confused as to how many times you need to hit next, it's kind of helpful to see there. And then within this portion, obviously, you can then go in and define. So if I had 3 or 4 in there, right, as I can create in different availability domains. Select where you want it to be created. On the fault domains, you can create this, or you can let the computer determine, or you can let the Oracle Cloud determine which is best. You can select a subnet. I actually haven't created a subnet here, so I'm not going to actually commit all of this because I don't have the networking pieces in place. But again, you'll see that it will show you an error telling that you have to have that. So, and you can do that again for as many as you want. If this is something where you are attaching these to a load balancer, and this is going to be, all kind of like the back-end set for your load balancer, you do have the options to go in here. You can select those load balancers. I have not created this either, and so I won't be calling that out specifically or anything else. But as you can see, this is about how easy it is to create it. I'm actually the next screen is just a review where you just basically finalize everything. But I'm going to hit cancel for right now, just so I'm not creating a bunch of things that I'm not supposed to. So back to this. Now, up until this point, we've basically covered all of the different pieces of the kind of core compute resources. But there are these 2 ideas remaining of containers and functions. So just as a kind of an overview, what's the difference between containers and virtual machines? So on the left-hand side, you'll see the virtual machine makeup. And they include all these pieces, right? There's the app, the binaries, the libraries, everything else is created there. And you can see the distinction across these 2 pictures are the bottom boxes. So whereas your VM has your hardware and your hypervisor included, and then as you can see, within each VM, there's the kernel and the operating system. Essentially what we do with containers is we abstract that up a level. Instead of having to recreate that kernel or operating system within each container, and therefore take up the space within each container, I say we, but the industry, I mean, this is something that happens all across, basically has said, let's keep the kernel and the operating systems out, and then we don't have to waste that space inside every single container. So they all, in essence, it's like almost like a second level of hypervisor, and all of these containers will then take advantage of and use this kernel and operating system. So, that's basically what I just said. and they're not tied to any specific infrastructure, and they could run anywhere. And this is the beauty of the containers, right? Docker being obviously the most wide used or the most well known, but there are others out there who use the same sort of setup. And of course, this makes it very easy to deploy, whether it's in on-prem and on our cloud, on a competitor's cloud, across clouds. This container has become kind of the de facto standard going forward. And where does this tie into compute? Well, what happens is you're still using some sort of underlying processing power, some kind of compute power. And so when it comes to all of this containerization or Dockerizing, you're not going to be charged for that. You're going to be charged for whatever resources are running underneath. And so that's where it becomes important to understand what it is you set up. And some people, have talked about, hey, what can I do with containers? How do I deploy them? There are, in essence, 3 versions or 3 ways in which you can deploy these containers. You can manually do that by SSHing into each machine and running Docker, etc. The pros of this, it's easy. Doing it once is easy. The cons is you would have to reproduce that for everything. So if you do have a simple setup and you only want to deploy maybe 1 or 2 containers, it's not that much of a deal. You could do it this way. It doesn't scale very well. You have other problems if you start to put on more. The second is to use some kind of scripting or automation or config management tools. And again, this is good because it integrates with basically most anything. It's pretty easily understood. But again, that's not really, you're not really going full scale with that. It doesn't still scale out as big or as easily as you would expect or hope for in every instance. And so finally, what's been come up with this idea or concept of orchestration systems. And these are fully automated. They're managed by somebody. We have our own version. I'll show you that on the next slide. The cons, of course, is that you do have to learn a little bit of additional tooling. There's some training required in there so that you understand how the orchestration system itself works in addition to the containers that you're using. So what does this look like for Oracle? We actually have what we call Oracle Kubernetes Engine. If you've never heard of Kubernetes, it's oftentimes abbreviated as K8. In Oracle, we call ours Oracle Kubernetes Engine, which is OKE. Now, again, this also came from an open source, and I believe it was Google who created Kubernetes, and it has become sort of, again, the de facto standard, although there are other groups that do this. It's this open source automation tool, and it really does help you manage and take control of all of your container deployments. And OKE, being Oracle's version, is the fully managed, scalable, high available, etc. service that Oracle owns, and it can be used quite extensively. It's built essentially. What we did was we said, hey, this all of this stuff that we have out there right now, which is, it's great for individual developers, but when you step in as an enterprise organization that has a very complex architecture, structure, IT landscape, you're going to need something bigger than somebody manually going in and managing all of your deployments or especially all of your containers. And so Oracle Kubernetes Engine does that for you, where it basically puts the enterprise spin on everything and allows you to be a little bit more nimble when you're dealing with that kind of an environment or with that many resources. So that's as far as I'm going to go with containers, because other than that, we probably have to start going into what the config files and everything look like. So I'll leave it there, but again, understanding that the underlying compute resources are what really are most important there from our perspective. Finally, we're going to talk about functions. So if you don't know what functions are essentially, they're very small, or at least in comparison to what we've talked about so far. They're pieces of code that typically are specific to a certain, like one task, or they do one thing. And now we store them as Docker images in a Docker registry, of course, and then we invoke or call on them through a different service. In Oracle's case, what we do is we have a couple different ones that can do it, but events or streaming services built into our Oracle Cloud Infrastructure can then trigger these functions. And when they do that, they run, and as you can see here along the bottom, you push your container to a registry, you configure the function trigger, and then the code runs when it's triggered. And the only thing you pay for then in that situation is the code execution time. So all of these other things that are happening, so like this configuration of the file or the trigger, or even when it's triggered, those things don't incur an extra cost. It's whatever underlying resource then is necessary to execute the function that you've written or the code that you've written. So as that says right there, it's just the execution time that goes into that. So with that, then I think I'm going to just kind of summarize what we've talked about today. Talked a little bit about the compute basics, right? We understand a little bit better about bare metal, hopefully, virtual machines, and then the scaling that can happen within, vertical, horizontal scaling, or auto scaling. And then we talked briefly about sort of the containers and where they work. And I realized that as we did this, I skipped over the whole diagram that I had here. And the reason why I didn't go into it is because when you look at this, a lot of just the vocabulary changes, right? The smallest thing you can have within OKE or Kubernetes is what they call a pod. And the pod is essentially just a container that holds your other containers. And they sit upon a node, which is your instance, essentially. So that node is another word for the instance that's running everything. And as you can see here in this architecture, we have it split up by default domains. And so we have different nodes in fault domains 1 and 3. And then within those nodes, we have several containers, put into our pods. And this is where your orchestration tool will come in, because instead of having to go in there and modify or change every single container within the pod, you could then change it at the pod level, or even at the node level, or even globally. So that's where your OCIR, or Oracle Cloud Infrastructure Registry, or your Kubernetes engine, basically, orchestration tools would come into play. So sorry with that. I think that's about all that I was going to cover today. I appreciate you being here. Just a reminder that we are planning to have another session here, which will be still OCI fundamentals, but we're going to talk a little bit more about the storage services, the different options, cold storage, hot storage, archive, etc. And with that, I will go to maybe the Q&A and see if there were a couple different questions or anything that was asked there. Okay, so how is fault domain different from availability domain? So yeah, this is a great question, and sorry I glossed over it. So within Oracle Cloud Infrastructure, we have actual physical differentiations for where our data centers are located. So at the highest level, we have what are called regions, and these are regions within a specific geography. So for example, we have one region called Oracle, or OCI East, which comes out of the Ashburn region in Virginia. And then we have one which is the West, which comes out of the Phoenix region. Now within each of those regions, we have availability domains. So these are within that smaller geographical location. So within the Phoenix region, there are 3 separate individual, my mind just blanked, but there are 3 separate data centers within that region that are housed separately. They have different power, different places completely. So in the event of natural disaster or something like that, chances of all 3 of those being hit are minimal. So it's kind of a high availability, disaster recovery setup within the cloud, where we have a backbone between the Ashburn region in Virginia and that goes all the way to the Phoenix region. And if, for example, you were to lose something there, you could go all the way out. Now, within each of these data centers, within each of our availability domains, there are logical separations. Now, these aren't completely separate hardware, but what we've done is within that data center itself, within the Phoenix region, we have subdomains that we call fault domains, and each of these then has separate power, separate backup, separate heating, cooling, but it's within that smaller data center, right? So anything that would big enough to knock out the data center would knock out all 3 fault domains. But for instances of, say, patching or running upgrades or something like that, we always guarantee that we're going to have 2 of those fault domains up and running, while, say, that 3rd is being patched. And so that way there's no data loss or any kind of impact to you as a customer. So hopefully that answers your question. If not, feel free to chime back in. So yeah, so the other question was, did I hear that there's no charges for scaling up? For every new resource scaled up, is there no charge? So um, yeah, let me be careful here. And I guess that's what the safe harbor statement is for, right? Um, but yes, in essence, if you are scaling up new instances, the act of scaling up does not cost you anything. It's the cost of usage for whatever you scale up, if that makes sense, right? So we're not going to charge you $100 just to add a third instance. We're going to charge you for what that third instance actually does. So if you spin up a bare metal, and the cost structure for these are a little bit different, right? Bare metal is, you're reserving that space, so obviously it's going to be a little bit more costly. If you spin up a bare metal, there is a charge cost for that bare metal just sitting, regardless of it's idle or using any compute resources. With some of the other VM shapes that we're talking about, you're not charged for that VM shape just sitting around. You're only charged when it actually starts running, so what it's actually doing. So without going into too much of the details, and I'm not really the sales guy who knows all the different pieces and the cost structures, but in essence, no, you're not charged for just putting on a new instance. You're charged for whatever that instance actually does and how much running it does, except for in the instance of bare metal, I guess, where if it's just sitting there, you're going to be charged. And then the third question I saw here was, can you show us Kubernetes on the OCI instance? I can. I think it'll take too much time for me to give you a great demo for that. That's actually planned for a later session, so I'm going to defer to that until a future session. We have a little bit more time to do it justice. I would hate to get on there and show you a few things and just confuse you, but I 100% will set up a different session where we can go through Kubernetes in detail. So with that, I believe that those were all of the questions that I saw. Let me double check. And so in the chat, somebody also asked, does auto-scaling incur downtime? Typically, no. This obviously will depend on the setup. If you have your rules set up in such a way that you wait until, say, 90% of capacity on your incoming or your existing compute resources, and then you trigger the rule, and what you're asking for the auto scaling to do is to spin up, say, 10 instances. If they're big instances or if they're instances with a lot of complexity in the boot volume, those could take time to scale, right? So the same amount of time it would take to scale up your initial instance. So in that sense, I guess there's a yes and a no. There's no downtime in your existing instances. That auto scaling will not impact what you're already doing on any instances that are already active. However, there is that inherent time for booting or bringing up the new instances. So in that instance, or in that case, I guess I could say there is downtime because you can't use them immediately until they've been fully provisioned and are active and everything else. So hopefully that's what you're asking there. And yeah, just double check. All right, great, perfect. Okay, I don't see any other questions, and so I think I'll go ahead and I'll turn it back to you, Tara, if there's anything else that you want to add or any points that you wanted to make final. So thanks everyone for joining. Feel free, obviously, to give me any feedback if I'm speaking too quickly. If I say too much, that's fine too. But more importantly, if you have any feedback in terms of the level of depth or complexity that we're going to here, or if there are other things you would like to see, very much appreciate you asking about Kubernetes. Definitely something we can talk about in the future. And with that, I'll let you all go, and I appreciate your time. Thanks.
Thank you everyone for joining us. We hope to see you next time.